Okay, so as we continue to work with ellipses, the equations we're going to focus on, exact same as the equations we've seen when we were graphing. So let's just revisit. General equations here are x minus h squared plus y minus k squared over a squared and over b squared. Notice, remember, it's always got to be equal to 1, and a squared is always greater than b squared in both of these. So when your a squared is larger, it's horizontal. When your when your a squared is under x, it's horizontal. When your a squared is under y, it's going to be vertical. And the way we find our foci is with that c value. So the c value is the distance from the center to the foci, and we take a squared minus b squared to get c squared. We have one more term we want to talk about here, and it's something called eccentricity. So that measures the ovalness of an ellipse, kind of the shape of it. So the eccentricity of an ellipse is given by the ratio E equals C over A. Same C and A that we're talking about, with the C being the distance from the center to the one of the foci, A being the distance from the center to one of the vertices. That E value is always going to be between 0 and 1, so it's not going to be negative. And the closer it is to 0, the closer to a circle it is. The closer to 1, the more just kind of smushed it is, or the more like narrow it would be. Okay. So our goal for today is going to be writing some equations. So as we write equations, a lot of times drawing a little picture can be really valuable. So let's start with writing the equation of an ellipse. So we have plus or minus 3, 0. So we have positive 3, 0. And negative 3, 0. So these are our vertices, so that means we know it's going to be a horizontal ellipse. Our center is right in between, so center is going to be at 0, 0. And we're told the foci is 2, 0. So from this information, what I know is that it's a horizontal ellipse. So that means our A value is going to be under x, B is going to be under y. So our A value, that's the distance from the center to one of the vertices, which our A value here is 3. So A squared will then be 9. Our center's at 0, 0, so that's h and k. We still need to figure out our B value. So we're not given our covertices. We don't know these points. But what we do have is our C value. So we can use that. Remember, A squared minus B squared equals C squared. Well, the distance from our center to our focus is 2, and that would be our C value. So C is 2. We already determined A is 3. So we have 3 squared minus B squared equals 2 squared, or 9 minus B squared equals 4. Subtract 9 from both sides, we get negative b squared is negative 5. Divide both sides by negative 1, we get b squared equals 5. And that's what we're trying to find. We're just trying to figure out what b squared is. So we don't even need to find b, and that would be 5. Okay. So we draw a picture, we figure out the information we have, and then we kind of go from there. All right, so next one. So we have foci at 0, 0 and 0, 8. So our foci are vertical. So that means our ellipse is also going to be vertical. So that means our A value, or the larger value, will be under y. We know the center is directly in between the foci. So that'll be our center there. So in between 0, 0 and 0, 8 would be at, 0, 4. So we'll have x minus 0 squared plus y minus 4 squared. So we need a squared and b squared. We're told the major axis has a length of 36. So the major axis is the longer of the two. So that's going to be our vertical, since it's a vertical ellipse. And it has a length of 36. So that means the whole thing has a length of 36. So that means halfway between would have half that, or 18. And that's going to be our A value. Our A value will be 18. So A squared would then be, let's It's not what I know off the top of my head. 324. So that'll be our a squared value. We still need our b squared, so we can probably go about that in the same way using a squared minus b squared is c squared. So we know a squared is 324. Our c value is the distance from our center to one of the focal points, which is just 4. So c squared would be 16. Subtract 324 from both sides, we get negative 308. So b squared would be positive 308. And there we go. So again, just kind of using the information you have. All right. So you have 2 left. I'd like for you to try both of those on your own. Remember, number 3 has your E value, so think eccentricity. E represents, remember, C over A. So keep that in mind as you're going through. Pause the video, give those a try. Okay, we're back. So let's graph what we have. Vertices at positive and negative 5, 0. So the center is directly in between, going to be at 0, 0. And since those are our vertices, that means our major axis is going to be along the x. So we've got x minus 0 squared, y minus 0 squared, always equal to 1. So our distance from the center to a vertice is 5, so that's going to be our a value. So a squared is 25, and that's along the x because it's a horizontal ellipse. We're told E equals 3 over 5. E is just C over A, so that means C would be 3, and we already know A is 5. So again, let's use A squared minus B squared is C squared. So A squared is 25. C squared would be 9, because 3 squared is 9. Subtract 25 from both sides, we get negative B squared is negative 16, or B squared would be positive 16. And there we go. For the last one, we have a center at 2, 3. So it'll be x minus 2 and y minus 3 squared. We have a vertex at 2, 6. So that means we're going to have a vertical ellipse. And the distance there would be a, which is 3. So that means a squared is 9. We're told our c value is root 8. So that means c squared would just be 8. So in terms of a squared minus b squared equals c squared. Sorry, I lost you. I'll give you a moment to kind of catch up. We plug in 9 for a squared. We plug in 8 for c squared. And b squared, well, that's got to be 1 because 9 times 1 is 8. And there we have it. So you're just using that general form, taking the information you have, sometimes drawing a little picture to fill in the missing pieces, to find your center, to find your a squared and b squared. And that's it.